Hello everyone, the topic is preparation of alcohol from ethylene oxide and grignard reagent. Grignard reagent we already know. The general formula is RMgX. Yesterday we have discussed it. What is ethylene oxide? This is ethene. This is oxygen. Now we know oxygen can make two covalent bonds. So suppose this oxygen is making two bonds with these carbon, so obviously this bond will break and a cyclic compound will generate this one. The oxygen will make two covalent bonds with two carbons like this, and obviously oxygen will have two lone pairs. Here it have, in normal condition, oxygen have one unpaired electron. With that unpaired electron, it will make bond with carbon like this. Unpaired electrons it will use to make bond with carbons. One electron of carbon this side, one electron of carbon this side. They will share it and covalent bond will generate. This was ethene. This is ethene. And this is ethylene oxide. Because oxygen is interrupted here, so we will call it ethylene oxide. Now, ethylene oxide and grignard reagents can prepare alcohol. Check how. This is ethylene oxide. Now, as we know, oxygen is more electronegative than carbon. So these electrons are more toward oxygen side. That's why these carbons are partially positive, partially positive. Here we have grignard reagent RMgX. Yesterday we have discussed it and we found between R and Mg covalent bond is there, and R is made up of carbon. Carbon is more electronegative than magnesium. So electrons are toward carbon side, due to which carbon is carrying partial negative charge. That's it. This is a negative particle. Here we have a positive particles. Any carbon it can attack because right now symmetrical condition is there. Now suppose this R is attacking on this carbon. So obviously first R and Mg bond will break and both electrons will go toward R. What was the condition of Mg? Plus 1 was satisfied by minus 1 of X. Between Mg and X, ionic bond was there. Now after this breakage, the second electron of magnesium is going with R. So it will release out as Mg plus 2 X minus 1. Okay, come here. Obviously this carbon will break bond. Which bond will break? Weak bond will break. Which bond is weak? This oxygen carbon, because electrons are toward oxygen. So when bond will break, both electrons will go toward oxygen. And this carbon will have a vacant orbital. That vacant orbital will be satisfied by this R with its lone pair. So next condition will be this. This bond will break and this oxygen will have now 3 pairs on it with a negative charge, because one electron of carbon is on this now. And this CH2 will make a dative bond with R like this. What about this O negative? This is Mg plus 2, unsatisfied by only minus 1 charge. So plus 2 need minus 2, minus 1 is there, one more minus 1 is there on oxygen. So it will combine with that. So we will get CH2, CH2, R, O, Mg, X. O will carry 3 lone pair with a negative charge, Mg plus 2, X minus 1. Mg is making ionic bond with oxygen with X ionic bond. Already yesterday we have discussed. So is it a alcohol? No, still alcohol we have to make. Second step, hydrolysis. We will apply hydrolysis on this product and we will get alcohol. Let's check. The product is this CH2, oxygen 3 lone pairs, negative charge, Mg plus 2, X minus 1, CH2, R. Let's hydrolyze it. Hydrolysis means reaction with H positive and OH negative. This H positive will attack on a negative particle. Here we have oxygen, which is a negative particle. OH negative will attack on Mg, and finally we will have CH2, CH2R, OH. H positive is coming without electrons, so it have a vacant orbital. This oxygen is carrying 3 lone pairs. So out of 3, 1 it will use to make bond with hydrogen. Check this. Now because one electron, this is lone pair, in this lone pair, 1 electron is completely getting shifted toward hydrogen, so hydrogen charge will finish out. It will become neutral. And oxygen was carrying -1 due to this extra electron. This it has provided toward hydrogen, so its charge will also finish. Now, side product MgOH, basic magnesium halide. And this is what we have, alcohol. In this fashion, ethylene oxides and grignard reagent followed by hydrolysis can produce alcohol. Let's check one original reaction. Like if reaction is given CH2, CH2, ethylene oxide reacting with suppose CH3, CH2, MgCl. First reaction. Second, hydrolysis. So what will be the product? What kind of alcohol will generate? Let's check. With magnesium, which carbon is attached? This carbon. So this carbon is partially negative. So obviously this will attack on these carbons. These are partially positive due to higher electronegativity of oxygen. Oxygen is partially negative. So this carbon will attack on this. Any carbon you can select, symmetrical molecule it is, same alcohol will generate. Bond will break, electrons will shift toward oxygen, which will be attacked by, between magnesium and carbon, bond will break like this. Now this oxygen will be attacked by magnesium. So firstly, it will generate CH2, CH2 and join from this carbon. Yesterday video I have also told you, I have also informed about this one, that this carbon which is connected with magnesium, that you have to use for bonding. So it will bond, it will make bond like this. This oxygen MgCl. What is the name of this Grignard reagent? This is ethyl, this is magnesium, this is chloride. Ethyl magnesium chloride, ethylene oxide. Okay, so this we got. Oxygen have a negative charge, magnesium have +2, chloride have -1. Hydrolysis. On hydrolysis, H positive, OH negative. H positive will attack on oxygen negative. OH negative will attack on magnesium positive. So finally we will have CH2, 4 carbon containing alcohol. If you will do IUPAC naming of that, you will find it is butane 1-ol. And side product will be basic magnesium chloride. Basic magnesium chloride. So similarly, you can prepare different type of alcohol. Here you no need to change number of carbon atoms. From here you will change the number of carbon atoms. Thank you very much. This is the end of the video.